This is 6.5b, the average value of a function. So there are just a few more I'd like to work through with you. And let's do, this problem says h of u equals ln of u over u, and the interval you're given is 1 to 5. Now remember, the average value of a function formula is the one that you need to know. And it says f sub average, AVE, AVG, it doesn't really matter. 1 over b minus a, those are your endpoints, the integral from a to b of f of x dx. Part A shows you where that formula comes from and at least one problem. So our endpoints are 5 and 1. So we have 1 over 5 minus 1, the integral from 1 to 5. And our function is ln of u over u with respect to u. So we're going to integrate with respect to u. So we have 1 over 5 minus 1 is 4. The integral from 1 to 5, ln of u over u. Now you cannot integrate the ln of u over u du. You have to use u sub, but our variable here is u, so let's not use u. Let's use a different variable. So I'm going to use m sub. I'm going to let m equal. Now, sometimes your denominator is your m value, but in this case, it's not going to be. So we're going to say ln of u, and then dm, our derivative of ln of u is 1 over u du. So du equals u dm. And then I need to decide bounds. So I have u turning into m. My u values are from 1 to 5, and my m will be ln of 5 and ln of 1, which is 0. Don't put ln of 1. Let's go ahead and put 0. So we have 1 over 4, the integral from 0 to ln of 5. It's an interesting bound, isn't it? And the function ln of u gets replaced with m. In our denominator, we have a u, and then our du gets replaced with u dm. Now these u's cancel, nice and pretty. Let me find a different color here. These u's cancel. So I'm going to clean it up, and we're going to say 1 over 4, the integral from 0 to ln of 5, and we just have m dm. When we integrate m dm, then this means we have 1 over 4. The integral is 1/2 m squared from 0 to ln of 5. So I have 1/8 parentheses ln of 5 quantity squared. Some people want to tell me ln squared of 5. We don't use that notation. We rarely square our value of ln, so don't do that. Minus the 0. So we end up with 1/8 parentheses ln of 5 squared. You can give a decimal value for that, or you can leave it like that, or you can put ln of 5 squared over 8. There's another one that says g of t is equal to 9 over 1 plus t squared, and the interval is from 0 to 2. So our average value of a function is going to be the integral from, oh, I forgot my other part. You do an average value, you have to divide. So 1 over 2 minus 0, the integral from 0 to 2, 9 over 1 plus t squared dt. Because t is our variable, we're going to do this in terms of t. So we have 1 over 2, the integral from 0 to 2, 9 over 1 plus t squared dt. I'm going to pull this 9 out and put it out here and call it 9 over 2. 9 over 2, the integral from 0 to 2, 1 over 1 plus t squared dt. Now this kind of looks like u sub, let u equal 1 plus t squared, but then your du would be 2t, and that's not up there to cancel, so it can't be u squared. This is one of those that you should know. It's an inverse tangent. So we're going to do 1 over 1 because a is 1. The integral of 1 over 1 plus t squared is the inverse tangent of x over a, and a is 1 as well. And we're going from 0 to 2. I'm going to come up so I don't scroll down. So 9 over 2 times the inverse tangent of 2 minus the inverse tangent of 0. Now, inverse tangent of 2 is not one of our special angles, so we leave it at that. but the inverse tangent of 0 is 0. And by the way, let's make a note that we always work in radians when we're in Calc 2. So our answer is 9/2 inverse tangent of 2. That is our best answer. You could get a decimal. It would be fine. I'm good with that. All right, let's look at one more. All right, this problem says that in a certain city, the temperature in degrees Fahrenheit, T hours after 9 a.m. was modeled by the function T of T. By the way, the capital T stands for temperature, the little t stands for time, equals 50 plus 14 sine pi t over 12. Find the average temperature during the period from 9 a.m. to 9 p.m. So what we're going to do is we're going to find the average value of this function because that's what gives us our average temperature. So we're going to say F sub average equals 1 over B minus A. If you write it every time, you might not forget to do all the pieces of it. The integral from A to B, F of X dx. So in this case, we're going to work in T. Now our interval, this 9 a.m. to 9 p.m., that means 9 a.m. is 0 hours. So this goes from 0 to 12 hours. That's our interval. I guess I don't want to put that there, but our interval is 0 to 12 hours. So we're going to say 1 over 12 minus 0, the integral from 0 to 12, and our function then is 50 plus 14 sine pi t over 12 dt. Now there's a couple ways to do this. You need u sub for the second term, but not for the first term, but you can use it for the whole thing and it's not really bad. So I'm going to rewrite this to be 1 over 12 because I need to do that before I continue. The integral from 0 to 12, and the function is 50 plus 14 sine of pi t over 12 dt. So I'm going to use u sub, and I'm going to let u equal pi t over 12. Now it's easier to think of this as pi divided by 12 times t, because when you look at it that way, you can see that the t is your variable and pi over 12 is your constant. So then du is pi over 12 dt. So dt is 12 over pi du. All right, so we're going to change this to say I have 1 over 12. Oh, bounds. So my bounds are going from t to u, and the top one is 12 and the bottom one is 0. So when I put 12 into u, I get 12 pi over 12, which is just pi. And when I plug in 0, we get 0. So 1 over 12, 0 to pi, 50 plus 14 sine of u times 12 over pi du. Now those 12s cancel. Nice. I'm going to pull this pi out. So I'm going to rewrite this to be 1 over pi, the integral from 0 to pi. And then we have 50 plus 14 sine of u du. So we bring down the 1 over pi. When we integrate 50 with respect to u, we get 50u. And then we have 14, and the integral of sine of u is negative cosine of u. And our bounds are from 0 to pi. So we're going to say 1 over pi. I have 50u minus 14 cosine of u, which is pi, minus, let me put a bracket in there. Let's do 50 times 0 is 0, minus 14 cosine of 0. Now cosine of pi is negative 1. So we have 1 over pi, and here we have 50 pi, and minus 14 times negative 1 turns into plus 14. I'm going to go ahead and put a bracket out here and keep my parentheses in the second part. So we're going to say minus parentheses 0. And then I have negative 14 cosine of 0. Now, cosine of 0 is the number 1. So here we end up with minus 14 down here. So let's keep going with that. So we have 1 over pi, and I have 50 pi plus 14 is 28. So that means I end up with 50 plus 28 over pi. Both of these answers are good. The underneath one is probably the one they're looking for if you're using Levisine. You could come up with the decimal. They probably should ask for that. If we were to do a decimal, this is approximately 59 degrees Fahrenheit. And the question is how many degrees? So I should go back and put parentheses here with degrees Fahrenheit because you need to label your answer and your answer is in degrees Fahrenheit. So the average temperature in that city using that function is 59 degrees Fahrenheit. I hope you enjoy this lesson. I like it. I think it's a fun lesson. Have a great day.